So we're going to start talking about similarity today. And this is a unit that you would have covered in grade 9 math. Now I know in grade 9 math, grade 9 was a little bit of an odd year for many of you, because for many of you it was the last year. And of course, schools shut down for about 40% of the year. And I know that different teachers cover the course in different sequences. So there's a strong possibility that some of you guys may have looked at this similarity when you were studying from home. And so we kind of may be all over the place in terms of what we know so far, in terms of similarity. But just based on what we know, I know that there are some people in this room that have some knowledge here. What do you know? Put up your hand if you know anything about similarity. If two objects or two shapes are similar to one another, what do we know about them? Yeah.
I mean, like these figures paper are similar, but they've got different text on them. So technically.
Okay. So if two things are the same size, are they similar? That's a good question. Yeah, what do you think? Let's talk about things that are different sizes first. Let's start with that, because that's a little bit more concrete. If two things are different sizes, how do we know that they're similar? Yeah. They look the exact same. Okay, so they will look the exact same. In terms of what? In terms of their shape. Okay, can we be a little bit more specific? Oh, let me just use a thinner. I don't know why this isn't working. Okay. Shapes or objects that are similar. So when I'm writing down here, you guys should be writing down into your notes as well. Shapes or objects that are similar. They do look the same. Yep. Oh, you didn't. Okay, here you go. But it has to be more than just looks, because remember we talked about this with parallel lines, perpendicular lines. Our eyes are not good enough to tell exactly. Okay, we used a word. I reminded you guys of a word from a unit that we did earlier this year. From our first unit, in fact. What was our first unit? If you're not sure, pull out your workbooks, take a look at it. We're going to need it later on anyway. Yep. Okay, that's fine. You could try and look at someone else's. Most of you guys should have them here, but I only see one person pulling them out. You're all going to need them later, so you may as well do it now. First unit, chapter 1. What's that all about? Look at the table of contents. We want to get a general overview of what that first unit's all about. Proportional, yeah. So shapes or objects that are similar have dimensions that are proportional.
You wrote R 3 times.
Oh, thanks. You can use your discretion as to whether you want to write R twice with a line through it once, or if you want to just write it once. I'll leave that up to you. Okay. Now, it is hard to understand from a just purely definition that's just in words, so we're obviously going to look at an example. Okay, let's take a look at an example. Let's take two rectangles. So firstly, when we're looking at a rectangle, what are the angle measures of the four angles in a rectangle? 90 degrees, okay? Okay, so we're going to look at, let's say, that one and this one. Okay, so firstly, we're looking at the two shapes. Okay, yeah, they're different sizes. Do they look like they're kind of the same though? Do they look like they could be similar? Yep, they're both rectangles. That's a good start. They both have the same angles. That's a good start. Now, how do we tell for sure? Well, what we have to do is we have to compare a few things. Within a rectangle, okay, rectangles have specific dimensions. What dimensions do we refer to when we're looking at a rectangle? What are the two dimensions called? Yeah, length and width. So what I'm going to do is I'll label with the smaller one, I'll label the length and width maybe with a lowercase w and l. So this will be lowercase w and lowercase l. And this one will be uppercase w and uppercase l. Okay? So if we wanted to know for sure, then what we need to do is we need to be able to compare width to width and length to length. And if those proportions are equal to one another, then the shapes are similar. That's one way of confirming similarity. Another way, well, let's actually do that first. Okay? So if we compare I'm getting distracted, and I can't get distracted when I'm teaching. So this is a warning. If this continues, you're going to have to move seats. Okay? Okay. So I'm going to compare. Let's say I compare width to width. And I'll do it in a fraction. And I'm going to compare length to length. Okay. Well, if I look at width to width, what's the size of the smaller width? 4. And the bigger width? 18. Okay, and the smaller length? 6 over 27. Okay. Now, can I reduce that? Yep. Okay, so this is something, and again, this is a few units ago, but if you have a fraction button on your calculator, you could use a fraction button to do that. Okay, that's not the way that I'm going to demonstrate it on the board, but obviously that's a tool that's available to you. What I'm going to look for is a common factor. Is there something that 4 and 18 is there something that both of those can be divided by? 2. Yeah, so I'm going to write 4 as 2 times 2 over 18 as 2 times 9. Okay? Shh. Now what happens with this 2 over 2? What's 2 divided by 2? 1. So these ones cancel. And I'm left with 2 over 9. Not 9 over 9. 2 over 9. There we go. Okay, let's do the same thing here. Is there something that both 6 and 27 is divisible by? Well, they're not both divisible by 2. Is there something else that they're divisible by, though? What else is 6 divisible by? 2 times what is 6? 3. Is 27 divisible by 3? Yeah. Okay, so they're both divisible by 3. So 6 is 3 times 2 over 27 is 3 times what? 3 times what is 27? 9. Yeah, and again, if you're finding the fraction reduction really tricky, that's okay. You've got fraction buttons on your calculator, okay? So I'm just showing how it works, but you don't have to rely on this. Okay, and the 3's cancel, and we're left with 2 over, I did it again. 2 over 9. There we go. Okay, what do we find about these two proportions? What do you see about these two proportions? They're equal. Yeah. Okay. What does that mean about these two shapes? What does that mean? If the proportions are equal. They are similar. Yes. Rectangles are similar.
9?
Okay? Now, this is one way you can show similarity, is by comparing width to width and length to length. But that's not the only way that you have to do it. The other way that you can do it is you can compare width to length within a shape and width to length within the other shape and show that those proportions are equal. So we'll do it that way as well. Okay? So this is another way of doing it. Or we can compare this. And sometimes when we're solving problems, we may need to do it both ways. Okay, so another thing that we could do is within the smaller rectangle, we can compare width to length. And within the big rectangle, we can also compare width to length. Okay, now I don't have the picture up, but some of you guys may remember, what was the width and the length of the small rectangle? You guys have it in front of you, actually. What were those values? 4 and 6. So this is 4 over 6. And this one, for the big one, was what? 18 over 27. Okay. Well, if we reduce these as well, okay, these are both divisible by 2. So 4 is 2 times 2 over 6 is 2 times 3. Okay, and these cancel. And we're left with 2/3. 18 over 27, do you guys know what these are both divisible by? The biggest number that they're both divisible by? 9, good. So this is 9 times 2 over 9 times 3. And again, the 9's cancel. So we're left with 2 over 3. Okay? So you can also compare dimensions within each shape to tell if there's proportionality. And in fact, we see, or if the proportions rather are equal, and we see that they are. Okay, so that's another way that we could prove that they are similar. Okay? So this is kind of a brief overview of what you would have seen before. Now, another word that comes up with similarity is something called scale factor. How many people, just put your hand up if you remember scale factor? Yeah, put your hands up really high. Okay, a bunch of you remember scale factor. So this is kind of tricky, but some of you might get it. If you took this 4, if this was your original, the small one was your original, and the big one was your scaled version. Does anyone know how to figure out what the scale factor here would be? No? Basically, the scale factor is what do you need to multiply the original by to get the new one? Does that make sense? So sometimes it's easy to tell, okay? If the original one is 2 and the new one is 4, then you doubled it. You multiplied it by 2. So the scale factor is 2. Yep?
Could the scale factor be a ratio?
It could be a ratio, yes. So sometimes it's expressed as a ratio, okay? And in fact, that's a good way to start to figure out what it is, okay? One way that we can figure out a scale factor is this way, okay? Okay, and sometimes you can think of a scale factor as producing like a model, right? Like if you're thinking about, some of you, I think at least one person in this class has told me that they want to be an architect. So if you think of an architect building a model of a building, right? The actual thing is going to be the skyscraper. The model is going to be the scaled version. Does that make sense? Okay, so you can think of the original times the scale factor equals the model, or the new version. Now what that means is to get the scale factor, if we wanted to isolate scale factor, we're multiplying it by the original. So to get it alone, we would divide by the original. Okay? And sometimes I've actually described this as the scale factor is the new one over the old one. Or you can use the word new over original. Okay, so you may want to make a note for that. New version, okay, or you could use the scaled version. These are all sort of synonyms for the model or the scaled version, okay? Now, if the original one was our smaller one in this case, right? So if this was our original, I'm just going to redraw them really quick. So this was 4, this was 6. This was our original. And this is our new one. 9. No, it wasn't 9, it was 18, right? And 27. This is the scaled version. Okay? Or you could use new version. Okay, to get the scale factor, you have to take a pair of corresponding sides, like the length and the length, or the width and the width, and just put them into this little equation, right? So for example, the scale factor is going to be 27 over 6, because we're comparing length and length. And the new length is 27, and the old length is 6. Or 18 over 4. Because the new length is 18 and the old length is 4. Okay, so you could do it that way. It could be 27 over 6 or 18 over 4. And these have to be the same, otherwise they're not similar. So you guys actually put those into your calculator and tell me what you get. What is 27 over 6? 4.5. And what is 18 over 4? Yep, it's also 4.5. Okay, this is also 4.5. Yeah, the same scale has to be applied to all sides for it to, in fact, be a similar shape. Okay, so that's another thing that we're going to look into in more detail as we go through this unit. Okay, we are going to kind of power through this quite quickly, though, because many of you, how many people have seen Similarity before? How many people, just raise your hand if this is not the first time that you've seen this? Really? For a lot of you, you're not raising your hands. So many of you have not seen this before. Interesting. Okay, well, we'll have to see what the pace is like then. Okay, some of you guys may have done it in grade 9, like after March, right? Okay, so let's actually get into some examples. And what you're going to see is that there's going to be quite a bit of proportional reasoning that comes into this. Okay. Now, I'm not sure if this is showing up on the smartboard really clearly. I may actually have to redraw. This is 8.5 inches, 3.4 inches, 2 inches, 2.6 inches, 6.5 inches, and 6 inches. There we go. Okay, that's a little clearer. Okay, all right, so Tara has drawn a scaled diagram of her bedroom so that she can sketch different arrangements of her furniture. On her diagram, the walls have the following lengths. So this is what she's drawn on a piece of paper, okay? So this length is 8.5 inches, this length over here is 3.4, etc. Okay? Here's the question. If the longest wall in her room is actually 12.75 feet, how long are the other walls? Okay. Well, the longest wall is 12.75 feet. Which wall on her diagram is that going to correspond to? Which letter? A. Yes. How do you know it's A? That's the longest. Yes. So if we're told that 12.75 is the longest wall, that has to correspond to the longest wall on the diagram. Okay? Now, if we want to find all the others, if we know one set of proportions, then we can use that proportion to figure out all the other ones using proportional reasoning. So what we're going to do here, at least to get the ball rolling, is use proportional reasoning. And with proportional reasoning, if you remember, what we had was we had two proportions equal to one another. Each proportion looks like a fraction. Does that ring a bell? Yeah? And what we had was that we know 3 out of 4, and we're missing one of them. Okay, and then we had to solve for the one that we were missing. So what I'm going to do, just to kind of make the labeling easier, is all of the walls have been labeled on the diagram with lowercase letters. What I'm going to do is I'm going to make the actual walls, I'm going to denote those with uppercase letters. So I'm going to call this one A with an uppercase so that it's easy to connect them up. Okay? Now I know one pair. I know big A and I know little a. So that's going to be one side of my equation. And then for all the other ones, I know the littler letters. And what I'm going to be looking for is the big letters. And I can start wherever I want. So let's say I wanted to start with B. Okay, now do I want to know the capital letter B or the smaller letter B? The smaller one? Which one am I trying to find out? The capital one or the smaller one? The capital one. So remember how we can set up our proportional reasoning equations with either one on top? Which one do you think we should put on top? The big B or the little b? the big one, because that's the one that we're trying to find. And that one's easier. It's easier to solve when the unknown is in the numerator. So let's say we're trying to find side B. Okay, well, one side of our equation is going to be B over B equals, the other side has to be a pair that we know. And we know capital A and little a. So that's the side that we're going to use. Capital A over little a. Okay, now we just have to fill in all the values that we know. So we don't know what capital B is, that's what we're trying to find. But we do know what the lowercase b is. That's 6 inches. Okay? What is capital A? What's capital A? 12.75 feet over, what's the smaller? It's 8.5? Yes, 8.5 inches. Okay, how do I solve this equation? How do I isolate B? Yeah. Multiply by which? What am I dividing B by? 6. So what do I need to multiply by? 6 on both sides. And I'm actually going to multiply by 6 inches, just to show you guys how the unit analysis works. This is kind of cool. Not only do the 6's cancel, but the inches cancel too. Okay? Now on the right side, the 6 doesn't cancel with the anything, but the inches do cancel. And so what's the unit that you're left with at the end of the day? Feet. And that's what we want, because the capital B should be in feet. Okay? So you don't need to show me, this is called unit analysis. You don't need to show me that, but it actually does work out that way. Okay, so B is going to end up being 12.75 times 6 divided by 8.5 feet. And that is 9 feet. Okay. Do you guys want to do one more together? No. Do you guys want to try the rest yourself? No. Okay, so I'm getting some no's. So if you want to do one more, if you want to go on and do the rest yourself, go for it, but do it silently, please. I'm going to do one more side with everyone. And then I'm going to let you guys do the other ones yourself. Okay? So let's just kind of do this in alphabetical order. Let's say we do side C next. Okay, so again, are we looking for, but I said you need to do it silently until I'm done talking. Okay? Let's say we're looking for side C. Are we looking for capital C or little c? Are we looking for capital C or little c? The big one. Okay, so if we're setting up two fractions, which c should go on top? The numerator, or sorry, the big one or the little one? The capital one, because that's the one that we're trying to find. Okay, now, question for you. Do I have to use a over a as the other side? Yeah, now I have another option. I could also use b over b because I found capital B and lowercase b. So the more pairs you find, the more options you have for the other side. So you could use a over a, and a over a is 12.75 over 8.5. But capital B is 9 feet. And lowercase b is what? 6 inches. Those are kind of nicer numbers, right? Because we don't have any decimals. So I'm going to use capital B over lowercase b instead. Okay, so you may want to make a note here. You could also use a over a. It doesn't matter. As soon as you find a pair, though, that's an option. Okay, now we're going to fill in what we know. So lowercase c is 6.5. So capital C, that's what we want. Lowercase c is 6.5 inches. Over, now we use this 9 and 6. Those are kind of nicer numbers. 9 feet over 6 inches. Okay? And then to isolate C, what do we need to do? What do we need to do to isolate C? What are we doing to capital C right now? What are we doing to it? Yep. Is that what we need to do to isolate it? What are we doing to it right now? We're dividing it, yeah. So we need to multiply it by 6.5 inches. And we need to do that on both sides to keep the equation balanced. Okay? So when we cancel those, and again here the inches cancel, you don't need to show me that, that's okay. As long as you answer in feet at the end of the day. This ends up being 9 times 6.5 divided by 6. And how much is that? Yep. 9.75 feet. Okay? All right, so I'm going to give you guys a couple of minutes, and what I'd like you to do is to find sides D, E, and F. Okay. Example 2. So if triangle ABC is similar to triangle XYZ, and the following angle measures are known, what are the angles of the remaining angles? Okay, so one thing that you guys need to know about similarity is that when we are told that two shapes are similar to each other and we're not given a diagram, then the letters that are given in the order A, B, C, okay, the first letter in the first triangle is going to correspond to the first letter in the second triangle. Okay, so A is going to be the same as X. B is going to be the same as Y. And C is going to be the same as Z. So that's one thing that you need to know. When you're told that shapes are similar, you need to know that. Also, when you're naming similar shapes, which we're going to get into later this week, you also need to know that. Okay? Now what I would do here is kind of draw it. We're given two angles. So when I'm given angle A and C, what I like to do is draw like a, whoops, I don't want that. I want this. Uh-oh. Okay, there we go. I'm given A and C. So I draw those along the horizontal. And then we talked about in our angles unit about reference. Okay? And so I can kind of picture what 30 degrees looks like. 90 degrees is like a corner. 30 degrees is about a third of that. So 32 degrees is going to be like that. 48 degrees is about, it's a bit more. So it's going to be like that. So wherever those two meet, that's going to be the third one. That's B over there. And it doesn't have to be perfect. So that's one of them. And then X, Y, Z, if I draw that one, what I need to remember is that X is going to be the same look as A because it's the letter that comes first when I'm naming them. Okay, so maybe I'll make it smaller. We don't actually know if it's bigger or smaller, but we just know that they're similar. Okay, so maybe it'll look like this. So this one, the first letter here is A, the first letter there is X. So A is on the bottom left, so X has to be on the bottom left. Okay. C is on the bottom right, and that's the last letter. Z is the last letter here, so that's on the bottom right. And then B is in the middle, and Y is in the middle, so Y's got to go on top. And now what I'm going to do is I'm going to fill in the angles that I know. So A is 32 degrees. and C is 48 degrees. Okay, and then Y is 100 degrees. Okay, we want to know what the other angles are. Well, if we know that they're similar, what does that mean about the angles that correspond to one another? If these two shapes are similar, what do we have to know about angle A and angle X? If the shapes are similar. What do you think? Could similar shapes have different angles? Yeah? If I had a rectangle, and this was 2 and this was 3, and then I had another shape that was like a parallelogram, where this was 4 and this was 6. So I have multiplied the 2 by 2 and the 3 by 2. The side lengths are proportional, but the angles are not equal. Are these shapes similar? No. So not only do the side lengths have to be proportional, what about the angles? What do the angles have to be? The same, yes. Angles also have to be the same. Okay, so for shapes to be similar, and we'll talk more about this tomorrow when we're actually going to be asked to justify if two shapes are similar or not. Okay, not only do side lengths have to be proportional, but also angles have to be equal. Corresponding angles have to be equal. Okay, so with that knowledge, what does angle X have to be? 32 degrees, yeah. So angle X has to equal angle A, which means angle X equals 32 degrees. Okay? What about angle Z? What angle would that equal? It equals 48. It's the same as angle C. Okay, so angle Z is 48 degrees. And what would angle B equal? 100. Yeah, because it's the same as angle Y. Okay. Another thing that I just want to mention to you, because I don't think we said this before, there is a symbol that we use to show that two shapes are similar. So I'll show it to you right now, and you can write this down. We would say that triangle ABC is similar. It looks like this. It's just one line, and it's like a squiggly line to triangle X, Y, Z. And again, the ordering of the letters is incredibly important. If I wanted to call this triangle, instead of ABC, CBA, then I would have to change this triangle to, instead of XYZ, ZYX. Because the corresponding vertices, the corresponding corners, have to be in the same order. Okay? All right, last one. Okay, example 3. If a house is 40 feet long, 35 feet wide, and the top of the roof is 27 feet above ground level, what will the corresponding dimensions be of a model built so that 1 foot is approximately represented by ½ an inch? Yep. Can you wait for 3 minutes? This one won't take long. Okay. Okay, so I'm going to be really boring, and because I'm not really good at drawing like houses with triangular roofs, I'm going to pretend that this house is just like a box shape. It can be like the modern Art Deco kind of thing. I don't know, some people think that's popular. So 40 feet long, 35 feet wide, and 27 feet tall. There we go. Some of you who are better artists than me, and there are many of you in this class, can do a better job of this than I will. Okay, so this is 40 feet, and this is the length. 35 feet is the width, and 27 feet is the height, is the top of the roof. Again, I'm going to pretend that the roof is just flat to make my drawing a little easier for me because I'm a little impaired in that department. Okay? Now what we're told here that on the model, 1 foot is represented by 1/2 inch. Okay? So how long would the length be in the model? What would 40 feet be represented by in the model? Well, each foot represents 1/2 inch, yeah. 20 inches, yeah. How many people can see why it would be 20 inches? Does that make sense? Some of you? Okay, so for some of you, this is going to be really intuitive, right? Because 1 foot is 1/2 inch, so we just like have all of these and then switch it to inches. Some of you are going to be like, oh yeah, that makes sense. How many people are like, oh yeah, that makes sense? Okay, if you are in that category, then what I want you to do is open up your workbooks and turn to page 262 to 263 and start working on questions 1 to 4 individually. For those of you that are kind of confused on why would it be 20 inches, what I'm going to do is I'm going to do this question using proportional reasoning. Okay? So what I'm going to do, actually, instead of using, I'm going to use capital letters. So let's make this 40 feet, and this is the actual. So this is the length. 35 feet is the actual width, and 27 feet is the actual height. Okay? Now, if we want to find the model, yeah. Okay, if you kind of know why it would be 20 inches for the length and whatever it is for the width and height, then you're off to the races. Okay? If not, then I want you to follow along with what I'm doing. Okay? Well, on the model, let's say we're trying to find the length. I'm going to call the model length lowercase l. Okay? We don't know what that is. We do know what the actual is. Does that make sense? We know that the actual one is 40 feet. So I'm going to say length over length equals, now what we know here is that 1 foot actual equals 1/2 inch model. This is what we're told. This is almost like a conversion factor when we were doing measurement. Okay? Now the model goes in the numerator. That's what's in our numerator here. So I'm going to use this almost as a conversion factor. And instead of writing 1/2 inch, I'm going to write 0.5 inches. I'm going to convert it to a decimal. So what I'm going to put on this side is 0.5 inches over 1 foot. And this is going to be my conversion factor for the other side of the proportional reasoning equation. Okay? Now what I need to do, though, is I need to fill in the actual length, which is 40 feet. So this is going to become length over 40 equals 0.5 over 1. Because my actual length is 40. Okay, now how do I isolate L? What am I doing to it right now? What am I doing over here? Dividing. I'm hearing someone whisper it. What happens in a fraction? What math operation happens in a fraction?
Divide.
Division. Thank you. So the opposite of that? multiply by 40. And so we get that L equals 0.5 times 40 divided by 1. So do that on your calculator and tell me what you get. (0.5 times 40 divided by 1. What is that? 20. What should the units be if it's the model? The model is done in what units? Look up here. Happens to the best of us. What units is the model done in? Think about, like, are you going to draw, 20 feet is like the size of this room. Are you going to build a model that's the size of this room?
Yeah.
Really? That's pretty ambitious. Yep.
Well, if you're building a model the size of the room, aren't you just building it?
Yeah, you may as well build the house. Look up here. 1 foot equals half an inch in the model. So what units are used in the model? Inches. Okay? We can do this for all of them. So for the width, maybe we'll use lowercase w. So I'm using the same equation. Instead of w over w, or L over L, I'm going to use little w over capital W equals 0.5 inches over 1 foot. Because remember, this is almost like a conversion factor. It's going to be the same for all of it. Okay? And the actual width is 35 feet. So W over 35 equals 0.5 over 1. Okay? And then again, just like we did here, we had to multiply by 40. Here, because the denominator is 35, we got to multiply both sides by 35. And then these cancel. Okay? And then W is going to equal 0.5 times 35 divided by 1. And that works out to be 17.5 inches. Okay? And then you can do the same thing for height. And what you might actually start to notice once you do a few of these is what you're actually multiplying by here. 0.5 divided by 1 is just 0.5. So you're halving all of them. And if you start to notice a pattern like that, then you can just use that, right, and accelerate the process. But the height's going to be the same deal. Okay, so h over h equals 0.5 over 1. And the height is 27 feet, the actual height. So h over 27 equals 0.5 over 1. And then again, we have to multiply by 27. And these cancel. And that, I think, is 13.5 inches. Okay? So what I'd like you guys to do now, we have about 10 minutes, is start working on these questions. You could probably do at least half of them before the end of class.